Hello everyone, this is Victor Momo from Excel Moments, and in this video I want to show how to use the lookup function to find the last non-blank cell in a row. You obviously can also work in a column. For this video we would use the same data that I used in my last video on using the XLOOKUP function, where I did mention that you could actually use an interesting lookup construct which has existed on Excel forums for a long time. What I want to do in this video is try and break it down, explain why and how it works. So in order to do that, we would have to look at the lookup function in itself, understand how the lookup function is designed to work, and then we can take it from there. It may end up being a two-part video, but let's see how it goes. Okay, so let's start up. I have a few notes here which I've taken off supportoffice.com, which is where I typically go to look up functions to understand, how they are structured, the syntax, and some remarks to know where and when, they wouldn't work. So typical of most lookup functions, for most of us who are familiar with like a VLOOKUP, HLOOKUP, XLOOKUP, you typically have a lookup value, something you're looking up, right? Then you have a lookup vector, which for like VLOOKUP will be like your table array. Then you have your result vector, what you want to return, which for like the VLOOKUP would be using your column index argument to determine, what column would be returned. Okay, so that's simple enough. But the important things about functions most times are, notes, and they are extremely important. Now, if you look here, it's written here as important. It says the values in the lookup vector must be placed in ascending order. So this is one of the reasons why you may not use the lookup function like your conventional VLOOKUP, which can work irrespective of how the data is sorted. So it says it must be in what ascending order. So if it's numbers, right, negative to 0 to positive, alphabet A to Z, false to true, because false is 0, true is 1. So it must also follow that. So if your lookup vector doesn't have its items arranged in ascending order, then you may actually get a wrong result. Okay, so like it says here, lookup might not return the correct value. So that's one thing to note. And these are the bits and pieces, that make that function work, taking advantage of, this understanding. The next thing I want you to note here is down here. It says if the lookup function can't find the lookup value, the function returns the largest value in the lookup vector that is less than or equal to the lookup value. It sounds like a lot of English, but what it means is that if in your lookup vector, the highest value you have there is 7, then if you're looking up a value like 9, it's going to default to 7 because it can't find 9, so it just takes the largest value in, the the lookup vector. That's what it uses. This is going to come in very, very handy in this lookup function. So I just wanted you to note those few things. I will show some examples to buttress, some of those points now. Okay, so here is an example where we have, just a small lookup table which has, codes and colors. So 1, 2, 3, 4, and equivalent colors. So what I want to be able to do is just to put a lookup value here. So more or less just put a number and be able to return a column. Simple enough. Here I want to use the lookup function. Of course, we know we can solve this with a lot of other functions. So I can put a lookup value here, say 2. Then for the column, I'm going to use the lookup expression. I should say it at this point that the lookup has two, syntaxes, but my focus will be on the first one. So lookup. So what am I looking up the lookup value? In this case, is 2. Simple enough. One thing you need to know about your lookup, and that's why it's called a vector, is because it's either going to be one row or one column. Your lookup vector cannot be, 2 columns or 2 rows. That's the meaning of that word vector. It's one row or one column. So in this case, I'm looking up 2. Obviously, I'm going to look it up here, right? I can do Control Shift down. So look for 2. Wherever you find it, I put a comma. It says result vector. So the result vector is optional, which means I may or may not put it. If I don't put it, what it just does is if it finds 2, it just returns 2. If it doesn't find 2, it returns an error. Okay, so but in this case, I want it to return, the colors. And one thing you must also note is that your lookup vector and your result vector must have the same dimensions. So if it's 5 rows, it should be 5 rows here too. And you do this. Okay. Now, do you see that? So 2 gives us red. Let's try 6. 6 gives us white. Now, just to tie in to this point here, which I have also copied and pasted here, that if the lookup function cannot find the lookup value, the function matches the largest value in the lookup vector that is less than or equal to lookup value. So what this means is that if I look for anything larger than 6 now, which is 9, because it can't find it, it defaults to 6, which is the largest number it can find in the lookup vector. So let's change this to 9. See that it's still white. Change it to 100, it's still white. Change it to 6.01, it's still white. So long as it is above 6, which is the maximum that you have there, it returns 6, it defaults to 6. So what it means is that it always defaults to, in the way this data is sorted, to the last row, because it assumes that it is in ascending order. So meaning it defaults to the last row. But if this was in a column, it means it will default to the last column because the largest number is assumed to be in the last column. Take note of, these maybe phrases, catchphrases, or whatever you want to call them, because I'll take advantage of them creating the lookup expression later on. So that's one thing, to note here. And this is just how it works. It's very simple. Now, I want to do another example before I go into, what I really have. Okay. So the next thing is here we have some students, we have their scores and we want to grade them. And we have, you know, a lookup table here or a grading table which tells us, okay, what scores, you know, um, fall into what grades. Of course, if you want to really, really be basic, you probably write 0 to 100 and fill all the alphabets. But we take advantage of the fact that, lookup defaults, to what it can see, the largest value you can see, and use that to actually create an expression here. So what I'm going to do here is just going to do the same lookup. I'm going to select the score. Here, I'm going to look it up, obviously, in here. My lookup vector is going to be the grades. So if you are looking for example 43, it knows that 43 is in between 40 and 45. So what it's going to do is going to default to 40. If you're looking for 57 now, it knows 57 is between 50 and 60. So since it's larger than 50, it defaults to 50. So it's always going to the value just lower than the value being sought. Okay, so A, and let's see if this all makes sense. Oh, forgot to lock that. That kind of shocked me there. I'm like, what's going on here? Okay, so control enter and then double click to go down. Okay, excellent. So everything looks fine. 83 is A because 83 is greater than 70, and it goes to A. So anything greater than 70 here obviously falls back to 70, and that's just the way it works. Now there's something I want to show you here so you see why the construct we would use at the end works. Let's change this 50 to maybe an error. So let me do something like 1/0. Now see what happens. The lookup function still works, but it doesn't give the correct answer. Well, what's 50 supposed to be? 50 is supposed to be C, right? And anything between 50 and 59 is supposed to be C. So now look at this 59 here. Because it can't find, 50, it assumes that 59 is in between 45 and 60. Because this row, for example, now, this in its mind doesn't exist. Because there's an error, it ignores the error. So what it's seeing is it's seeing 45D and it's seeing 60B. So when you then give it any number between 45 and 60, it defaults to 45. So your formulas look like they are doing the right thing, but it's giving you the wrong answers. Okay, so it's just ignoring that. See 54 here. 54 is supposed to be a C, but now it's a D because as far as it's concerned, all I can see is 45 and 60. So The lookup function also ignores, errors. So let's change this back to 50. You would see that that 54 becomes C. Okay, so now you see a few features or nuances of the lookup function, how it's able to default to the largest value just smaller than the lookup value, how it's also able to ignore what errors. So what it means is that once you give it a value that is larger than the largest value in your lookup vector, it defaults to the largest value that it has in lookup vector, or if you may, to the lowest value in terms of direction now. So the last value it can see here, or if it was, in a row, the last value you can see here, and it ignores errors. Okay, so let's now go into the example proper. Looks like it fits in time. Let me see how many minutes I've spent. Oh, 10 minutes. It looks like a good time to move it to the second video. So I think I'll move this to the second video and we'll see how that goes.